So the beta for Red Hat OpenStack Platform 17 has recently been released. So I wanted to make a few videos to look at some of the differences between RHOSP16 and 17 and discuss some of the ways you can troubleshoot the new deployment methodology and the new hardware provisioning process. They're things that we've already covered in previous videos with RHOSP, such as the new networks v2 changes with the new NIC config files, the new provisioning process where we deploy the networks, the VIPs, we provision the nodes, doing the network config, and then we run the overcloud deployment and ephemeral heat. So I want to do a high-level introduction first, just run through a normal deployment, and then we will follow that up with some code walks and how to debug each of those steps along that way. So if you get stuck with anything, you know where to look and you know how it should be working. So the documentation is now up and active, but it's a little bit rough around the edges. It's very much a work in progress as it's still beta at this stage. So if you go down to director installation and usage, you can basically follow through here the same way you would with OSP16 or any release before it. The first part is all very similar. You know, you're going to install RHEL 9, register it with Subscription Manager, attach the right repos, do an update, install Triplo client, install the Undercloud. All that stuff remains unchanged. I guess some things that I will point out here though is, so in section 6.3, when we get to attaching the repos, these are still RHEL 8 repos at the moment. So just make sure you change these to RHEL 9. You literally just change the 8 to a 9 and that will work fine. And the other thing is during the container image prepare, when you render this file, by default, it's going to have RHOSP-RHOSP-RHEL 9. We want to do RHOSP-Beta as the namespace, and I'm going to show you that right now. So let's switch over to the terminal here. So we're going to be deploying this all in OpenStack. I have a test project called OSP test, and we can see I have deployed a 17 director and just a 17 standalone node. So we will provision just the standalone role on that virtual machine. And then I've just written a quick Python script to read from my network data v2 file and go through and create the network. So these are all the networks that we will use within that project. So let's switch over to the director node now. We can do. So you want to make sure that your virtual machine or your director node or whatever you're deploying it on is registered to Subscription Manager and you're able to access all of the repositories. So make sure you attach to a valid pool that contains the beta subscriptions for OpenStack, and then just follow those steps. As I said, just change the 8s to 9, so you can see all the repos have this RHEL-9. And I will include this command for you as well, which goes through and changes that for you. So this will be in the comments. You can just copy and paste from this, and that should attach all of the correct repos for you. So once you've done that, just as usual, install Python Triplo client, copy over the undercloud.conf file, then come in, edit the undercloud.conf file as required by you. So if we search for, so I've just added in the local IP as the IP address that I'm getting from OpenStack for the director node. So you can see here, that's the IP address that my director node has on the control plane network. So I've just swapped that out for here. It's really easy to look at if we do this. We'll remove all the comments. So you can see these are the things that I've changed. So the gateway I'm supplying as the director node as well. And then we've just got a containers-prepare-parameter file. So we'll take a quick look at this. So inside our containers-prepare-parameter YAML file, so I've just removed my credentials from this one, but make sure you add your credentials in so that you can pull the containers from the Red Hat registry. So this is what I was talking about down here, this namespace. By default, this will be RHOSP-RHEL 9. We don't want that, we just want to change that for beta. Now that will pull the correct containers. So we can leave everything else in this file as it is. And then we can just run the OpenStack Undercloud install, which will install your Undercloud. So I've done that to save some time. So we have a look. We can see that we're running quite a few less services now compared to RHOSP16. So there's no Mistral, no Zakar, no Nova. no Swift, no Glance. They've all been removed now. So this is all you'll get. So if we have a look at the memory usage here, we're only using 3 gig and I've given it 22 gig. So this is a much lighter weight deployment of Director to what we've had traditionally in the past. And you can see that namespace there that I'm referring to being the RHOSP-Beta one. So once we've done that, we can really move into the next stage where you would import your nodes. Now, because I don't have an ironic driver for OpenStack installed here, I've just pre-provisioned that node. I will assume that you're going to do the introspection and the node provisioning like you would normally do. If not, you just need to install osnetconfig, open vSwitch, make sure open vSwitch is running, configure the heat admin user. So if we log into my standalone node here, for example, so this is my standalone node that I have provisioned. Now I have created a user called heat admin. Not that we really need this user anymore. This user is kind of irrelevant now. By default, we'll just use O admin for everything. But just keeping with what's going to be familiar for everyone, I have created heat admin here. So then just making sure that heat admin is able to run sudo commands without the password. So you can see there that I have set it up to run commands without needing the password. So we can run sudo ls, that's fine. And then just make sure the key is copied over here as well. So in authorized keys, I've got the director key here. So once we've set that up, we're all good. We can proceed to the next step. So what we want to do is go through that network provision, VIP provision, node provision. So if we take a look here, we'll have a look at the network data.yaml file. So this is just all of our networks. This is exactly the same as what's on my Git repo and I've shared before, the same as the Baremetal environment underneath it. The only thing I did change was this external network. Instead of being VLAN 4, which is my physical VLAN, I've changed it to VLAN 254 so that it can work in this environment without conflicting with the actual provider network. So once we've done that, we can run OpenStack overcloud network provision -- output to the Baremetal networks deployed.yaml file, and we'll pass it as an input the network data.yaml file. So now this will run some Ansible playbooks and go out and provision those networks on your Undercloud. So once this is finished, you'll be able to run OpenStack network list and see these networks provisioned. And we need to do this because we're using ephemeral heat, and heat actually can't speak with the Neutron service running on the Undercloud. It just starts in an isolated pod, renders your templates into Ansible playbooks, and then it shuts down and goes away. So it has no interaction with the services running on the Undercloud, which is why we also don't use Nova. So once we've done that one, we can do VIP provision. So OpenStack overcloud network VIP provision. The stack will be overcloud. We're going to output it to a VIPs deployed file, and we're passing as an input this VIP data YAML file. So for this one, we just want to include any networks that we want VIPs on. So in my case, I'm doing external and control plane. So once we have configured that file, very basic file, we can run network VIP provision, and this is going to create those VIPs in Neutron. So there'll be a couple of ports that are created as a result of running this command. So once those two have been executed, we can do OpenStack network list and see the networks that have now been created. So obviously if you were doing a composable network, that's where you would add it, is in that network data YAML file, and it would be created as part of this process. Okay, so once our networks and VIPs have been created, we're ready to deploy that standalone node. So let's take a look at our Baremetal deployment.yaml file. So in this is a really cut down version of what I have in my environment. So name is going to be standalone. We're going to do a count of 1. It's not managed because I've manually deployed it, so we include managed false. Now we just give it the fixed IP. So the fixed IP there, this will be the IP address that Ansible connects to when it wants to configure that node. So we can see that that's the IP address from our standalone node on the control plane network, which is 24.38. The next thing we're going to do is just include the network config file that we want to provision the node with. So let's take another look at that file. So I've just copied this from the defaults. If we have a look in here, the only thing I have done is added a NIC1 to it. So the single NIC VLAN by default will just use the single interface and provision everything on it. So I'm just going to keep this this first one here. So we will do type interface, name NIC1, use DHCP true, so that we're still getting the DHCP address for it. And if we have a look at osnetconfig-i, that tells us that NIC1 is ETH0. So if I want to ETH0, so we can see ETH0 there is this VLAN infra network. So we want to keep that just so we have an external interface to be able to access it from, so SSH in if anything breaks. So we don't want to provision any of the networks for the actual OpenStack deployment on that interface. That's simply for us to be able to maintain management of this node. So I've added that in to get the DHCP address so that it continues to pick that up from Neutron in OpenStack, and everything else will be configured on this OVS bridge now. So I just changed this NIC here to NIC2 instead of NIC1, and all of our networks will be created there. So we include that file in our Baremetal deployment YAML file as the template that we're going to use. That will be rendered by Ansible during the next step. So once we are ready with that, we can run the node provision. So we do OpenStack overcloud node provision. Stack is overcloud. We're going to pass in -- network config so that it provisions the networks and runs osnet config on that standalone node during this deployment. And we'll output this baremetal deploy.yaml file that can be included in our deployment. So this is probably the step that's going to require the most tweaking from you as a user. So if you don't have that extra interface like I do in this environment, and probably even if you do have it, you still want to be able to have a console access to this virtual machine. So or this physical server, like if this is a physical server like mine behind me, then you're going to want to have access to the iDRAC so that you can log in and just tweak any of these network things should it break anything. Right, so in my case, I can do OpenStack server show on 17 standalone. And we can see that this one is running on overcloud controller 0. So if I go here, log into my controller node, which is this one, and the virtual machine's name is, it ends in C5, so we'll do sudo virsh list so we can see that it's this one here, so instance 25, virtual console 25. So I bring up a console on that node. So if I really needed to debug something, I could do it with the console coming in this way. That does require that I set the root password on that QCOW image though. So if you haven't set the root password, then you will need to do that. And you can do that from here before you start this network provisioning process. So just log in, set the root password here. So sudo su password, set it to whatever you want, and now you'll be able to log in from that console. And then we can debug from here, right? So if anything does happen to go wrong during this network provisioning process, then we have that as a fallback. So you can see that that's finished there now. So now if we do IPOA, we can see all of our networks are provisioned at this point. And now we're ready to proceed to the actual overcloud deployment stage. So that's a really quick run through of this because we have already covered it in another video. I don't want to repeat myself too much. I'd rather spend some time deep diving into each of these steps. The other thing I would say though, just to help you out, is if you're a bit confused about this new file format for provisioning the nodes, that's okay. We do have some examples. So on the OpenStack /OO heat templates repo on GitHub, there's this Baremetal samples file, and in there you can see an example file of how to do more intricate things with this file. So for example, if you wanted to do fixed IP addresses, predictable IPs, then you would do that here. So you can see in this case we're creating 3 controllers and we pass it in that network template file. But then we also have this instances dictionary. So under here we have overcloud controller 0, managed true, so this is going to be deployed by Ironic. Then under networks, these are all the networks for overcloud controller 0. And then we do the same for controller 1. So we're still under the instances dictionary, we add another host name, we add the networks. And you can do this for all of the roles that you want to deploy in the environment. So it just gives you a bit more flexibility to manage the predictable IP addresses at this early stage without doing it as part of the deployment. So back at our director node now. So let's have a deeper look at this network provision command. So again, let's just quickly go back to GitHub, and this time we'll go to Python O client. Okay, so on the Python O client Git repository, if we scroll down, we've got this setup.cfg file. So if we go down and we find network provision, we can see that network provision here on line 62 will send us to O client v2 overcloud network and overcloud network provision. So what we do is we go O client v2 overcloud network, and now overcloud network provision is the class. So here it is here. So this is the code for what actually happens when you run that overcloud network provision command. You can see there that we have some argument passes, so you can pass it in the output file. So if we go back to the terminal, we can see I was passing it in an output file. So that is this one here. We can pass in -y, so if we have already done this and we wanted to make a quick change, then we can do -y and that will change it. We can pass it in a templates directory, but by default it will get the default OOO heat template, so use a share OpenStack OOO heat templates. And we can pass it in a stack name. So once we've done that, then we come down here to this take action section. So what's going to happen here is it will use the networks file that we passed it in, get the path for it. So if you do it in a random directory, we will get that fully qualified path. And then we're going to go through, set some extra variables that, we use that network file path, we use the output path, override is part of the, if you pass in -y templates. And then we do this run ansible playbook action. So this comes from the utils file, but we're going to run the CLI overcloud network provision.yaml playbook. So let's go back to our director node and let's go and find this file and have a look at what it actually does. So back on our director node, we're going to do sudo find in user share ansible name that. So there it is. So you can pass in exec vim. Don't have vim installed. Okay, so here's the file. Let's just install vim so we get some syntax highlighting here. Okay, vim's installed. So now when we open this file, we can see that this is the playbook that runs when we execute that command. So that's all it does, is it just calls this run ansible playbook and passes it in the playbook we want to run, the inventory, the working directory, in this case just a temporary directory, playbook directory, verbosity, so if you pass in --debug, that will increase the verbosity of the ansible playbook command. If you want to see this one, it's just in the utils py file. So it's just a function that helps to execute these ansible playbooks. You can see there all the possible options that come into this function, but the function itself is kind of irrelevant for what we're talking about. So just note that it executes the playbook, and that's the most important thing that we want to see from this. And this here is the playbook. So it goes through, gathers facts, sets up connection details, and then the tasks are load config from file. So we load the networks data file, set that as an ansible fact. We create the composable network, so we're using this OOO composable network module. We can go and have a look at that as well. We pass in the network data, then we populate the environment file, and we write out the environment file to the output directory that was specified. So we want to have a look at this composable networks module, for example. CD into user share ansible. Now in here we have a bunch of directories, so we want to go into plugins and then module. Okay, so here we have this O composable network.py file. So if we edit that file, we can see this is a Python file that just handles inputs and creating of composable networks. So it gives you some examples of how to use it there. And if we scroll down, we can see it basically just establishes a OpenStack client connection, and it goes through and it creates those networks. So using the net specs here, we can see it sets all this info to net specs, returns that. So we scroll right down to the bottom of this file now. I'll just set line numbers to make this easier for you guys to follow. So when this module is executed, it goes through and does a bunch of things, but one of the first things it does is it sets up the OpenStack SDK connection. So we use that con then, so con.network. So we can see here, for example, when we're getting the overcloud domain, we set network to con.network, find network, default network. So this is just an OpenStack SDK call to Neutron to look up the network information for this default network, for example. So if you are having any issues in this part of it during the network provisioning, this is where you can find all the information related to what's actually happening behind the scenes. So if you encounter a bug, this is where you can look into it and identify that bug, raise a bug on Bugzilla, we can fix that for you, but this will help you to reproduce it and narrow down that issue, because I personally, as I said in my last video, I find it really satisfying to find the exact line of code that broke things. So I want to give you guys the tools you need to be able to look into this yourselves. If you're looking into an issue with this provisioning process, then you know that Python O client first of all calls the Ansible playbook command, and that is running the Ansible playbook we just looked at, which includes some modules, and then we can look up the modules and see exactly what happens in each of those modules. So nothing is magic, it's all happening in a very logical way, and if you understand how to look into that, you'll be much better and much more confident at managing your OpenStack environment. So if we look at VIP provisioning now, so VIP provisioning is going to be the same. So VIP provisioning will be the same process, right? We'll go, it's going to be in the same file, but we'll go back and we'll do it all again for, practice sake. So just the root of the directory I've changed into stable Wallaby because OSP17 is based on Wallaby. We go down to our setup.cfg file and we want to look for VIP. So network VIP provision, so on line 64. So we can see this time it's in the same file, but it's using the class overcloud virtual IPs provision. So here it is here on line 221. And we can see the same thing. We've got a bunch of argument passes, and then we go into this take action section. Take action section ultimately ends up setting the extra vars and then executing the playbook. Here's the playbook name, and we pass in those extra vars that you can see down below. So let's go find this playbook now. So we'll do the same thing. We'll do find user share ansible, name is that one. So you can see there it is there, exec vim. So very, very similar thing happening here. We set a bunch of information that we need. We have some custom modules that are being created here, and then we output it to an environment file. Exactly the same process. Let's spend a bit more time on node provisioning this time. So but instead of doing it back on the GitHub link, let's do it on this director node so we know where the code is located on the director node. So we'll change to root first so that we don't need to sudo all the time, and we'll cd into user lib Python site packages O client v2. So in the v2 directory we have this overcloud node py file, so we vim that file. So let's search for provision here. There it is, class provision node. So again, we have a bunch of arg passes. This one takes a few more things. You can pass in an overcloud SSH key, a Overcloud SSH user. So this heat admin will be removed soon, and we will just use OO admin instead, but you can change that during this provisioning command if you want. If you have a special user that you like to use while you've provisioned that node, you can do that. Network config, so this is whether or not to run OSNet config. Once we've passed all our arguments, very similar thing, we come down into this section where we set all the extra vars, so the stack name, Baremetal deployment, etc., all the information you passed in the arg passes above, and then we execute the Ansible playbook. So everything is looking very similar. So this time we'll go find this Overcloud node provision file. So there's a bit more that happens in this file. We go through and we find all the images that we need to provision those nodes. Then we go through and we have a look at the roles that have been provided. We look for existing instances that have been deployed. So your Baremetal environment file might have had 2 computes before, and now you're adding another 2. So 2 are going to be pre-existing. That's what that will do. It will go and find those 2 that already exist and then register them. For the ones that aren't provisioned, so if this is not found, then it will go through and reserve those instances and then start provisioning them. So here we go, here provisioning the instances. So we go through and we boot them up, we provision them with the Overcloud full image, create the network ports, populate the environment files, etc., and then ultimately we write that environment file out to wherever you've specified as your output location in that case. So that's the first thing that happens. Is there anything else that happens in this provision section? So we do this run roles playbook now. So we can go find this run roles playbook that's coming from OOO-utils, so OOO-utils. So let's have a look at what that actually is. Do a find on that one, and we're all the way to the top of the file. So we can see that from OOO client import utils as OOO-utils. So we know that it's going to be in the utils.py file. So we can go back directory. In here we can see we have this utils, and we can do a search on roles playbook. So you can see here this run role playbook. This is the function that it was executing. This one here. So what that does is it takes an inventory relative directory playbook, limit hosts, and extra vars as arguments, and we can see there that it uses run Ansible playbook from the utils directory to execute the playbook. So let's have a look at what that playbook was when we pass that argument in. So we go vim v2 run role playbook. So this roles file dir, so we need to find what roles file dir is. Do a quick search, we go back. So we can see it's using role file path, and role file path roles file path. So it is the absolute path for the past args for input. So we can go back up. We're looking for past args for input. So input is just the first argument that you're passing without anything else. So the Baremetal deployment YAML file, for example. So if you at any point weren't sure what this was doing, what we can do is we can just do some debugging here. So with open debug file as debug file, we can do df.write, and then we can write in any of these variables that we're unsure of. So we can do an f, and then we'll do roles file dir, close that off, And now we can run the node provision step again, and we should get a debug file. So we're on the node provision step again, and we'll check that debug file. So this is a good way, if you're confused about anything that's happening there, it's basically just, putting print statements everywhere to find out what's happening. It's a great way to learn how the code works, great way to become more familiar with the whole process, is to just, dig around, experiment, deploy a lab like this. If you've got a couple of gig free that you can play with on a server or a desktop PC, deploy a director node, deploy a virtual machine that you can use as a standalone node, and just print things out, have a look at how things work. A good way to explore, become more comfortable, and just take your knowledge of the platform to that next level. So once this is finished, we will check for that debug file, and we'll have a look at what that variable was. Okay, so that's done now. So we have now this debug file here. So we can see that the roles file dir is just home stack. Okay, so all it has passed to that function is home stack. So if we have another tab and we reopen that again, so user lib python site packages O client v2 note utils, and the function we're looking for is run role playbooks, run role playbooks, so that one there. So let's see how it uses this roles file dir. So the inventory file comes from the working directory. We open the inventory file. We have this grow vols play. So we can see that in the output when we just run the node provision. We can see it running this playbook as well. Another playbook that we need to check on. So pre-network config for role in roles. So roles in our case is the third argument. So this one here, passed arg stack. No, 1, 2, yeah, so this one here. So over on the left side, we want to find out what roles is now. So roles equals YAML safe load. What's it opening? Okay, so we can see there that what it's doing is it's reading this input. Oh, we're in the wrong thing. So we do this YAML safe load of the input file. So we go up a bit more. You see the input file was that Baremetal YAML file. This one here, Baremetal deployment YAML. So then over here on the right side, we see that we do for role in roles, and we know that roles is that file. If role.get count1 is 0. So let's go back to the YAML file. Stack Baremetal. Baremetal. So we're getting the count. So if the count is equal to 0, then we continue. Else we come down to for x in role.get ansible playbooks. So if there was an ansible playbooks here, it would execute those playbooks at this point. So if not, we're not going to run anything there. So we're going to do this grow vols now one. So we will run the run ansible playbook on the grow vols play. And then if network config, then we're going to run this CLI over cloud network config playbook. So we can go and have a look at that one. I should just probably explain this Ansible playbook uses the Ansible deploy interface in Ironic to configure custom things about your environment. So I might be able to find an example of that back on GitHub. So you can see here under role properties, we have this Ansible playbooks, which is a list of dictionaries for Ansible playbooks and Ansible vars. The playbooks are run against the role instances after node provisioning prior to the network config. See this Ansible playbook section for more options. So you can see here, if we wanted to run the grow vols and pass it in some specific arguments, so we want to grow home by X amount, then we can pass that in here under an Ansible playbook section. So that would just be defined down the bottom here as a separate dictionary, Ansible playbooks with all the arguments that you need. So that would then go through and execute them at this stage here before doing the default grow vols which it wouldn't do if grow vols was specified here. But if you have your own custom ones, it'll do it here, then it'll run the grow vols, then it will do the network config. So let's go have a look at this network config playbook here and see what it's doing. So we can see there that all it's doing is including this role O network config. So to find the role, we can do the same thing, user, share, ansible, name. And in this case, it's a role, so we know it's going to be type of directory. So there it is there. So we can see that it's there, and we can then just cd into that directory. So it's going to import this role, just like a normal Ansible role. It's going to look for things in tasks. So we have a main file. In the main.yaml, these are the first things that will be executed as we execute this network config. So you can see that it goes through, creates OSNet config, for example, and then just goes through and executes OSNet config on those nodes. So that's how we can debug all of those different steps during that deployment process. So I'm going to leave it there for this video. That's a fair bit of information to take on board. In the next video, we'll take a look at the ephemeral heap process. So in this one, we just looked at the node provisioning, the network config of the Overcloud nodes, which has changed from the previous versions of Red Hat OpenStack Platform. In the next video, we'll use those files that we just created as part of this process and provide that to the Overcloud deploy command, and we'll see how that works with ephemeral heap. We'll do the same thing, we'll do a bit of a code walk, see what's happening with the ephemeral heap containers and how it all comes together, and how you can debug things if you need to debug at any point during that process. So I hope that's helpful. That's the very first part of node provisioning in Red Hat OpenStack Platform 17. If you haven't already, get out there, get it installed, raise some bugs. I'd be happy to hear your feedback if you find anything that you'd like improved. If there's anything you find that you don't like about it, I'm more than happy to have a look at it and see how we can fix that and make it a better experience.